Hi there. In this video we're going to talk about the Pythagorean identities in trigonometry. These are three very important identities that you're going to want to know. They're very useful, and they fortunately are very easy to derive. So let's go see how to come up with them. All right, we're going to do this by hand. I'm going to draw a quick sketch of the unit circle. All right, this is a circle of radius 1 centered at the point 0, 0. All right, now if I take any point on this unit circle with coordinates x and y, that determines an angle. When measured from the positive x-axis, counterclockwise, that's what it would look like. Now what I'm going to do is I'm going to drop a line vertically from this point down to the x-axis. Now when I do that, I hit some value here on the x-axis. What is that value? Well, that is the x-coordinate of this point, so that is the value x. Now what I have here is I have a right triangle. So if I take that right triangle and redraw it over here, a little bit bigger, you see we have the right angle here, we have the angle theta here. This distance over here is x. This distance here is y. All right, now what is this distance? What's the length of the hypotenuse? Well, we said this was the unit circle, so we know this length is 1, and so this is 1. Now when we have a right triangle, we know a very important theorem from algebra, and that theorem is the Pythagorean theorem. What does the Pythagorean theorem say? X squared plus y squared equals this distance squared being 1. We just have x squared plus y squared equals 1. Okay, great. So we have this picture. But when we talk about sine and cosine, we know that they relate to the x and y coordinates of this point. We know that x is the cosine of the angle theta. X equals cosine theta. And we know that y is the sine of the angle theta. Okay, well, if we just substitute these into the Pythagorean formula, what do we get? Well, x is cosine theta, so this is cosine theta squared, which we write as cosine squared theta. Y is sine theta, so this is sine theta squared, which we write as sine squared theta. And we see that that equals 1. This is our first trigonometric identity. Cosine squared theta plus sine squared theta equals 1. There are two more trigonometric identities. How do we come up with those? Well, let's write this over again, and we're going to do a little bit of algebraic manipulation. What I'm going to do is I'm going to divide this equation on both sides by cosine squared theta. When I do that, let's see what happens. Well, this is cosine squared theta divided by cosine squared theta. That's equal to 1. This is sine theta divided by cosine theta squared, right? But we know that sine theta divided by cosine theta is tangent theta. So this is tangent squared theta. And 1 over cosine theta is secant theta. We discussed this in the last video. So this is secant squared theta. And this is our second trigonometric identity. Let's do this one more time to come up with the third trigonometric identity. I'm going to rewrite our first identity. And instead of dividing by cosine squared theta, I'm going to divide by sine squared theta. Let's go through the same logic. Well, this is cosine theta divided by sine theta quantity squared. Well, cosine theta divided by sine theta is cotangent theta. So this is cotangent squared theta. This is the same thing divided by itself, so this is 1. And 1 over sine squared theta is 1 over sine theta quantity squared, so this is cosecant squared theta, our third and last trigonometric identity. So we have these three important trigonometric identities. Now this may seem like a lot to remember, but just what you really should do is just remember where it all came from. We have our very simple Pythagorean theorem, and we know that x equals cosine theta, y equals sine theta, so that's all you need to remember to get all of these. You can derive all three of these trigonometric identities just by knowing those facts. Here's a common type of question that requires us to use a trigonometric identity. An angle theta in the second quadrant satisfies sine theta equals 1/4. Find cosine of theta. So we know that the sine of the angle is 1/4. We want to find the cosine of the angle. We also know the angles in the second quadrant. What does that mean? Well, when we have the x and y axes, they subdivide the xy plane into 4 quadrants. Quadrant 1, 2, 3, and 4. These are the 4 quadrants. So we know our angle puts us into this quadrant. Okay, so let's see what we can do with this. Well, we know sine theta and we want to find cosine theta. So do we have an equation relating them? Well, indeed we do. We have the Pythagorean identity. The Pythagorean identity tells us that cosine squared theta plus sine squared theta is equal to 1. And this is true no matter what theta is. But we know that sine theta is 1/4. So this is the square of that, so this is 1/16. So what we have here is we have an equation that we can use to solve for cosine theta. I'll subtract 1/16 from both sides. And that means that cosine theta is plus or minus the square root of this number. And of course this simplifies because this is the square root of 15 divided by the square root of 16. So it's root 15/4. Now it's plus or minus. How do I know which one it is? Well, that's where this comes into play. Knowing that we're in the second quadrant tells us that we're over here. And remember that cosine of the angle is the x coordinate. So if my angle positions me somewhere over here, well, I see that my x coordinate must be negative. So that tells me that I need to use the negative solution of the two solutions that I got here. So in fact, as a final answer, I would write that cosine theta is actually negative root 15/4. That is my final answer.